Good evening and welcome to our presentation. Our team for this semester's research group is Group 1. Group 1 is comprised of myself, Marissa Martinez, Alexandra Ledesma, Jen Pang, Hitesh Endij, Nikhil Guruva, Shivraj Doshar, Azmath Ali Mohammed, Nabil Martinez, Rashvi Telkapil, Jagadish Philippartsty, and Natalie Cosgrove. This research that we conducted this semester was to optimize pipeline routes. This research will encompass how to calculate pipeline costs, selecting routes, environmental impact of the construction of a pipeline, and utilization of network modeling to select the optimal route overall.
So this is Hitesh, and I would be continuing on with the presentation. And my today's part is the methodology. So whenever we are planning to construct oil, gas, petroleum pipelines, it is always important to look at the bigger picture. So it means it's important to look at all the materials, the systems involved in the construction of the whole project, and the cost revolving around those. Therefore, it's important that we understand how the cost of the pipeline is being influenced and the factors contributing to it. So in reference to Rivka Aizia's work, in this research, we have these 7 components that allow us to calculate the cost of the pipeline. So starting off with the material cost, it basically means what kind of materials, the coatings, and the fittings that have been inculcated into the whole pipeline project. So throughout the pipeline, it's important that we must include the compressor, mainline pressure valves, and other regulatory stations that come under the station installation costs. The third cost is the telecommunication system costs. So the telecommunication system that we have used in this pipeline project is the SCADA, which basically means supervisory control and data acquisition. So this is a kind of data communication software which helps us in maintaining and monitoring the flow rates and the pressure throughout the whole system. The fourth cost is the environmental cost or the environmental permitting cost, which means the modification costs that we have made into the project to preserve the environment, followed by the ROW, which is the right of way costs. It's a generic cost which is included in every kind of project, and it is basically a land acquisition cost. Sixth is the engineering and the construction costs. It basically deals with the costs related to the design and construction teams of the whole project. Seventh is the allowance and contingency costs. These are the legal and regulatory costs. So these are necessary costs for getting your application filed from the authorities. Previous slide, please. So does having these components included, we now proceed with the proposing. So our first step in the whole procedure would be making a network of all possible nodes throughout the network, extracting all the elevation, the crossing profiles of each of the node that is in our network. Third, we have calculated the construction cost of each of the nodes in the network. And lastly, we have calculated the optimal route on the basis of the factors involved and the costs involved.
So hi there, I'm Nikhil, and I'm going to explain every stuff regarding Google Earth and the use of Google and Earth in our project. So we have used Google Earth Pro, a software advanced enough to provide access to high resolutionary images. In the beginning, we have started with marking the start point and the end points on the Google Earth. And then we have selected different nodes between these 2 points and then tried connecting all these and design possible different routes. As you can see in the image, we have designed 3 different routes in this project. The data which we have collected with the help of Google Earth are distance, which is the distance between 2 points in miles, the elevations, which is in feet, and we have tried to cap the elevation or the slope 1.3%, the number of crossing between these two, like the different nodes, and the population density.
Hello everyone, this is Rushvit. I'm going to explain you about the networking model which we have used in our pipeline project. So networking model is basically it's a special type of optimization model which is used for solving the optimization which is used for solving the optimization of the problems that has network in it. It is usually used in optimizing the problems that include transportation problems such as um, finding the cheapest routes between 2 points or finding the most optimum routes like pipeline between 2 points. So here, as you can see in the graph, um, we try to collect all the possible nodes in our route, and then and connect all these nodes with the branches, and then we try to calculate the pipeline cost of each branch in the in whole network, and then identified the best optimum route using Excel solver.
Hello, this is Shivraj. So I'm going to explain about the terrains which are used during the pipeline routing. So the terrain of a pipeline route has a large impact on the construction activity. If a terrain is encountered, the crew efficiency along with the equipments gets stagnated for a safe construction on a slope. Now, as the pipeline construction increases, the CO emissions and CO2 emissions also increase. So it is better to finish the construction as soon as possible, and hence the slope of any route should be kept between 0 to 15% in the desired areas where the pipeline route is to be maintained and constructed. Now, a pipeline route should always be rerouted if the slope is over 45 degrees at any single point in the network route. So here are the following locations which we have selected and the respective elevations in feet. Thank you.
Hello, this is Jagadish. I am going to talk about the crossings in our network. So each of our route will have different types of crossings. Like we do have main road crossings, we do have railroad crossings, we do have water bodies to cross with. So each and every crossings will be directly affected the project. So we require for if we come across the crossings, we do require additional crew, and we require additional construction time, and also we require it directly affects the cost of the project. As a result, we should be very important for us to minimize the crossings, or we should select different longer routes to avoid these type of crossings, or to carry out with the crossings with the shorter routes, thereby creating a designed and flexible route. As in the table on your right, we can clearly see from point A to point B, we have different types of cross. Like we do crossings of 7 major roads, and also like from point 2 to point 3, we do have like 3 roads and 1 canal. So in this type, we have calculated each and every from city to city how many crossings we had came across. We have calculated each and everything and came up with the optimal route.
Okay, my name is Alexandra. I will follow up explaining about the environmental impact. We use some methods to assist us gaining knowledge of how properly optimize our route selection. On top of all these wonderful reports and articles that we went through, like the UH1 and floors, I divide this section in three, where we have obstacles, pipeline routes, and phase impact. As one of my participants explained before, we are using 318 miles, and the construction cost will be around 160 million. The road that we found to be optimum is the cone that has a least number of crossings, which result in having the least environment impact. Explaining the obstacles it could be experienced in pipeline routing construction may include existing underneath structure, wildlife preservation areas, and wind farm. The environmental impact play key role in selecting a pipeline route. It may be possible to find a cheaper route that can have a higher impact on the environment, creating permanent damage to vegetation and wildlife habitat. But it was always important to achieve a balance between environmental impact and pipeline cost. We can achieve this planning the pipeline route that can be a smaller number of crossings through forests, natural water bodies, etc. This impacts the cost of fabrication, but is offset by the benefit of a slower deterioration, breakage, and repairs overall. This initial cost increase can be beneficial in reducing future preventive maintenance expenses. I can explain something that is very important in the last paragraph that we have broken this into two phases, construction and operation. The construction has a great impact on the ecology of the work area. So there are some excavations, soil compaction, and others. Instead of operation, that if there's some leaks, emissions, that can be helped by operators and avoid these issues by extra inspections and maintenance routines. Thank you.
Good evening, everyone. Coming to the costing of this project, as we all know, every project comes with a cost. In this case, the total cost of landing the 16-inch diameter can be done at an average cost of $528,106. This table shows the breakdown of the cost. It represents the installation cost per mile. Coming to the next slide, the diameter of the pipe is usually a big determinant when it comes to calculating the installation cost. For this project, the following is the breakdown of the installation cost per mile.
To add to what Asma said, we found the cost breakdown from Nathan Parker's UC Davis research report in 2004, but we only use the average material and labor data. For miscellaneous cost part, the environmental costs and permitting, allowance and contingency, stations, and etc. were added based on the actual constraints, major roads, rivers that were inevitable. The environmental cost was between 10 to 15%. Allowance and contingency was between 15 to 20% of the subtotal cost of the labor and material.
After the pipe installation cost, what follows is the round system. It entails the calculating cost of different segments. A product of the project cost subtotals to the distance of the segment, and it gives us the total cost for the pipeline installation in that respected area. The total distance is 317.84 miles, and the total cost would be 156,762,184.24. Now, Jinville.
Just jumping on that, the actual total cost is 168 million. And before starting with the calculation of the distance, what we did was we convert the slope of the elevation to horizontal distance to be more accurate. And after finding the final distance in miles, We multiply the overall cost per mileage times the distance that we got for the total cost per route.
For the optimal route, based on our calculation data for the pipeline route, using the networking concept and utilizing the solver option allowed us to determine the most optimum pipeline, in which the most optimal route was determined as shown in the yellow path here in this diagram. The pipeline's length is 318 miles and the construction cost is about 168 million US dollars. The most optimum route was found to be the cheapest because of maintaining a lower elevation and fewer crossings throughout the route, which resulted in having the least environmental impact.
Our goal in this research was to optimize our pipeline design to minimize costs and environmental impacts. We designed a network of various routes through which the pipeline can pass. We utilized Google Earth Pro to decide the optimal route, quantified the construction cost of each node in the network along the optimal route, factored in population density to minimize routes through more urban areas. We use a rate of 528,106 per mile, which included material, labor, permitting, and right-of-way / miscellaneous cost. The optimum pipeline route was calculated to be 318 miles. This gave us a construction cost of $168 million.
This is the conclusion of our research. Thank you for listening to our presentation.